As mentioned, the red line is the relative response variable per weighted record or exposure, scaled so that the base level, in this case garage, is exactly 1. Relative to garage frequency, street and train station frequency relativities are both 20% higher. 23% higher. The orange line is the relativity of the average modelled value for records in that level. It's analogous to the red line in that after each observation is scored with a modelled value based on the multivariate predictors in each observation, a one-way summary of this modelled value across each level in each predictor is computed and displayed as this orange line. If your model is performing well, the orange line should match the red line quite closely, i.e. the actual and predicted values should line up with each other. Now let's look at power, which appears a little bit different. Recall that we fit power as a straight line, since we checked the cont version of this predictor. For numerical predictors like this, the beta coefficient is the slope of the line. Now, fitting straight lines like this produces a simpler model, since we only need to estimate one beta coefficient for the whole predictor, rather than a coefficient for each unique value, except for the base level. By contrast, looking back at garage type, when we did have each model, each level fitted separately, we had 4 beta coefficients. Now recall that the confidence intervals of the beta reflect the upper and lower bounds of what the model estimates the beta should be. Now in the case of the beta representing the slope of a line, if the beta were at the upper end of its confidence interval, the slope would be greater than if the beta was at the midpoint. And in this case, where the beta is at the upper end of its confidence interval, the line would follow the upper tips of the intervals shown like this. Conversely, if the beta were at the lower end of its confidence interval, the slope would be shallower and the line would follow the lower tips of the intervals shown like this. That's why for numerical and cont factors, you get this fanning out of the confidence intervals like this. Also interestingly, with numerical predictors, the summed actual and fitted values in each band, shown by the red and orange lines, don't fit together exactly anymore. This is fine as long as there isn't a systematic over or underfitting over sections of the variable. If there was a systematic over or underfitting of, say, low power vehicles or high power vehicles, or low driver age or high driver age, then we might want to move from fitting a straight line to fitting a spline, such as a quadratic or a logarithmic curve. We will come back to fitting splines a bit later. Now just looking quickly at driver age, this was a numerical value that was fit as a cat, i.e. it was treated as if each band were a level in a categorical variable. Since each band is allowed to have its own beta coefficient, the actual and modelled fit together perfectly, within each band at least. But this is overfitting the data and leads to some problems. Firstly, there are 12 beta coefficients being fit here, making it a much more complex model than if we just fit a straight line, which would only require one beta coefficient. Secondly, there is no natural ordering being enforced. The beta for each level is all over the place. It goes up here, then it comes down, then it goes up again, then it comes down again. Each level has been allowed to fit perfectly, even to noise in the data. If we had fit a straight line then, like we did for power, the blue line would have a smooth, straight shape rather than the rough shape that we see. Now we want the model to reflect the natural process underlying the data rather than randomness in the data itself. Having the model fit perfectly to every up and down movement like this in the historical data probably won't generalize the model very well to future data, as well as a simpler straight line model would. As a compromise, we can fit a spline, which is basically a series of piecewise lines or curves over different parts of the age range. Since a straight line over the whole range might not be appropriate, where it decreases over this range and then seems to more or less flatten out after that.